Hey guys, welcome back to another video. Here I'm going to be going over a uniform circular motion problem. We're given this information. Uh, a bob of mass m is suspended from a fixed point with a massless string of length L. What tangential speed v must the bob have so that it moves in a horizontal circle with the string always making an angle of theta? And we're given a diagram right here. All right, so let's first start off with making some statements. But first, we need to realize that these are components of tension, all right, because it's hanging from a string. So we could call L the length or T for tension. And correspondingly, this is going to be, uh, hold on, this is going to be T cosine of theta. And similarly, this is going to be T sine theta. Now, you need to realize that this is also the radius, all right? And that's going to be important. And L sine theta, which is equal to the radius, all right? Now let's write some statements. Let's start off with the net force in the y direction. You need to realize that the it's on a pendulum, so it's not moving up and down, so the net force in that direction is going to be 0. Let's make a quick free body diagram for in the y direction. This is just going to be mg of the ball. It's going to be t cosine theta. And these two have to be equal since they're not moving up or down. So this is going to be t cosine of theta is equal to mg. All right. Now let's come down. Go in the x direction now. And this is going to be the centripetal force. The only force acting in the x direction is t sine theta, all right? And we know that that's going to be equal to mv squared over r. And remember, r is L sine theta, all right? L sine theta. Okay. Now what we can do is we are not allowed to express the answer in terms of t. So we need to cancel the tensions out. Now, how do we do that? All right, let's take a look at this equation. All right. This is going to be T is equal to mg over cosine theta. All right. Now we take this and plug it into this statement right here. So mg sine theta over cosine theta is equal to mb squared over L sine theta. All right. Now remember, sine theta over cosine of theta is nothing but tan theta. All right. So mg tan theta is equal to mv squared over L sine theta. These m's cancel out, and we're left with g tan theta is equal to v squared over L sine theta. Let's come down, I'm running out of room. Now let's isolate v squared as we're symbolically deriving the equation for the velocity. It's going to be L sine theta multiplied by g tan theta. All right, take the square root. You get v is equal to square root of L sine theta times g tan theta. And it's going to be your final answer. All right, it's extremely important to learn how to derive equations symbolically because on exams, they may not even give you the numbers. They're just going to give you some variables and they're going to ask you to derive it like this. Now, we have some extra time remaining, so I'm just going to go through what we did. You had to realize that this was the radius, all right? And then you had to cancel out the tension. So what we did was we solved for t in terms of m and g and theta, and then we plugged that back into this equation, and we kept simplifying, and we solved for v, all right? If you guys found this helpful, make sure to drop a like, and hit that subscribe button so you don't miss out on future content. Thanks for watching.